Okay, for the hardest part, in my opinion, is changing graphs. Like, let's say you have a slope on a distance versus time graph, but I tell you to change it to a velocity versus time graph, and then change that to an acceleration versus time graph. Or take an acceleration versus time graph and change it to a distance versus time graph, which is a huge jump. It takes a lot of practice, but let me just go over some basic things. Now, for those of you who take calculus, you'll understand a word called derivative. Maybe not right now, maybe much further into calculus, but a derivative is something pretty important that we'll, look at in calculus and we'll talk about for this. First, let me make sure. Good. Okay, covers me. Let's say you have a distance versus time graph. I'm going to do a very, very basic distance versus time graph. So, and I say, hey, let's change this to a velocity versus time graph. Well, if you remember, the slope of a distance versus time graph is velocity. So if you were to find the slope of this distance versus time graph, if you were to find the slope of that, you remember it would be a constant slope because it's a constant diagonal line. It would be constant. It would be the same slope. No matter what, you'll get the same value no matter which 2 points on that line you pick. So this says, if we were to say it, this says you are moving away at a constant rate. So what's a constant rate look like on a velocity versus time graph? Well, if you recall, a horizontal line. So first things first, one thing you really need to know is the derivative of a diagonal line is a horizontal line. So if I say go from a distance to a velocity versus time graph, and it's diagonal, on a velocity versus time graph, you'll do a horizontal. Now, you'd actually have to calculate to see exactly where to put it. Sometimes you have to estimate, but that's basically it. What's a derivative of this, of a horizontal line? Well, remember, the slope of a velocity, the slope of a velocity versus time graph is acceleration. And if you take the slope of a horizontal line, you know it's zero. So there'll be nothing. There's no acceleration. And then we can go the opposite direction. Let's say I give you this velocity versus time graph, and I said, hey, go make a distance versus time graph. So we could go the opposite direction. So if I say go the opposite way, velocity, so if it's a horizontal, it'll turn into a diagonal. Now, let's pretend I have an acceleration versus time graph. If I have an acceleration versus time graph, and I have a diagonal, and I said, make a velocity versus time graph. Oops, sorry, not diagonal. Other one. I have a horizontal, sorry. Let's say I have a horizontal, and I say make a velocity versus time graph. Well, remember, how did we get that horizontal? That came from a diagonal. Now, depending on where the horizontal line is, whether it's on the positive y or the negative y, will determine whether or not the slope is up or the slope is down. So that's important when we actually look at a real graph. So again, it'll look like that. Now, how can I get a diagonal? Well, diagonals actually come from this shape. If I make another distance versus time graph, let me erase this one, and get like a a curve like that, where my distance is constantly increasing at an increasing rate, that leads to this. Curves, the derivative of a curve is a diagonal line. And the derivative of a diagonal line is a horizontal line. And so it's very important you know how to go from which one. Okay, it's very important you know how to go from which. So again, let's just practice something real quick. Let's pretend this, my acceleration, had an upward acceleration. And I said, make a velocity versus time graph of that. Well, in order to get this diagonal, I had to have a curve there. Simple. Or let's pretend I said, hey, you have a curve on your distance versus time graph, make an acceleration versus time graph. Well, you don't need to make the velocity one, but you need to remember that it goes curve, diagonal, horizontal. Okay. If I have a horizontal here, and I said make a velocity and acceleration, can't. Because again, the derivative of a horizontal, the slope is 0. And if that's 0, this is clearly 0. Because if you have no velocity, you have no acceleration. Let's look at something like this. Velocity versus time graph. Here we go. All right. I have to make an acceleration versus time graph of that. Acceleration versus time. First, I know I got to make a horizontal line because I have on my velocity versus time graph, it's a diagonal line upward. So that's also, if I find a slope, it'd be a positive, so it's a constant positive acceleration. So let's just say it's like right here. So for a little bit, it goes like that. Then the velocity goes to constant, it's a constant velocity, which means the slope of that is 0. So what's that look like? Sometimes you'll see it like this, and then they'll just start making it right here. Sometimes they'll do it straight down like that, and then they'll go across. I've seen it both ways. So sometimes they have that line, sometimes they don't. Sometimes they just leave it like that. Then it gets to right here, and you'll have a negative, when I say right here, there you go, where the check is. That's a negative acceleration because you're slowing down. So it went boom, then 0, then to here, and then again, find this one. I'm just going to make a couple numbers up real quick. Let's just say this is 5 and 6. This is, I don't know, -5 and 0. So that would be -5 minus 0 is -5. So that would be an over, so that would be negative acceleration again. So then it would just be like, keep going like that. Keep going like that. So there you go. That's all I did. Now, if I wanted to change that velocity versus time graph to a distance versus time graph, again, in order to, since I'm going the other way, in order to get a diagonal, I need to have a curve. And then it went constant. Then it went to a curve like this. And then it sped up again. So, something like that. I mean, that's a rough estimate, to be honest with you. That's a rough guess. But something to that effect. The big thing to remember is it always goes curve, diagonal, horizontal. Curve, diagonal, horizontal. And then opposite direction. And just remember, it goes typically distance, velocity, acceleration. And so, again, if this is a curve, this one must be a diagonal. If this one's a horizontal, this one must be diagonal, this one must be curve. If this one is horizontal, the velocity, your distance must be a diagonal, and your acceleration would have to be 0. So again, it just takes practice, but again, this video is just a basic beginning kind of look at this stuff. So you'll get a lot more practice in class.